This will be for the con exercise, interpreting slope and y-intercept for linear models. Now, for these problems, you don't need to read the write-up. You can if you want to, but you don't need to. And all of them will either give you a slope or a y-intercept. All right, so just so you know, for your information, the y-intercept is where the line crosses the y-axis. All right, and since the y-intercept is where the line crosses the y-axis, at the y-intercept, it's always going to be x equals 0. Okay, so at x equals 0, y equals 37. All right, so whenever you see y-intercept, the x value is going to equal 0. And the y value is whatever they give you. So in order to interpret this, we are going to have to look at the graph. All right, so if you scroll down to the graph, we can see the x-axis here is study time in hours. And we can see the y-axis here is the score. So how do we interpret x equals 0 and y equals 37? Well, let's see. X is the study time, so the study time equals 0. And y equals 37, that's the score, so the score equals 37. So how do we put this into words? Well, somebody that didn't study, somebody that studied 0 hours, got a score of 37. So that's basically it. Let's look for that choice. All right, right here, answer D. The model predicts that students who didn't study at all will have an increased average score of 37 points. All right, if someone didn't study at all, that's going to be 0 hours of study time. And the average score would be 37. That's what we said. Answer D. If you read answers A and B, they're based on the slope. And we didn't have slope. We were given the y-intercept. All right, so answer D. All right, so again, you don't really need to read the write-up. And here we're given slope. Okay, so we have a slope of 15, and they want us to interpret the slope. Now remember, for slope, that's change in y over change in x. All right, so slope is going to equal change in y divided by change in x. All right, you want to make it into a fraction. Since it's 15, the slope is 15, we can make the slope equal to 15 over 1. All right, and these are both positive. So that means y increases by 15. All right, y increases by 15 when x increases by 1. Now we want to look at the graph and see what x and y actually represent. We're going to use this right here. All right, we can see from the graph the study time is going to be the x, and the score is going to be the y. So y is the score, and let me see. Since y goes up by 15 and y is the score, we can say the score increases by 15 and X is the study time. The study time increases by 1. All right, so that's going to be the answer. We want to look for the choice that has this answer. The score goes up by 15 when the study time goes up by 1, and that's in hours. Okay, so it might have hours in the answer, I'm not sure. We're looking for this. Answer C, the model predicts the score will increase 15 points for each additional hour of study time. All right, for all these choices, there's going to be 2 based on the y-intercept and 2 of them based on the slope. So hours is based on the slope. You can eliminate some answers that way. Answer C. All right, so I don't read the write-up on these. Here it says the y-intercept is 5. Okay, if the y-intercept is 5, the y-intercept is at x equals 0. And the y-intercept is 5. That means at x equals 0, y equals 5. All right, so let's figure out this interpretation. I'll write it off on the side here. X equals 0 and y equals 5. And let's look at the graph and figure out what x and y represent. All right, on the graph, the x-axis is hours playing sports. And the y-axis is the mood rating. All right, so since x equals 0, hours playing sports equals 0, and since y is 5, the mood rating equals 5. All right, so this is going to be our answer. It's probably going to say somebody that doesn't play sports at all has a mood rating of 5. Answer B, the model indicates students who spend 0 hours playing sports will have an average mood rating of 5. Answer B. All right, last one. The fitted line has a slope of 0.48. All right, so if the slope is 0.48, that means change in y over change in x is going to equal 0.48 over 1. Okay, remember you can put any number over 1 and it doesn't change the value. So since these are both positive, that means y increases by 0.48 and x increases by 1. All right, so let's see what x and y represent from the graph. All right, so for the x-axis, that's age in years. And for the y-axis, that's ear circumference in millimeters. All right, so y increases, or we can say ear circumference increases by 0.48 millimeters. And the age increases by 1 year. All right, so this is going to be the answer. Ear circumference increased by 0.48 millimeters. Age increases by 1 year. So let's find that answer. Answer A. On average, each 1 year increase in age was associated with a 0.48 millimeter increase in ear circumference. That's it.